Hello and welcome back to CS1322. This is lecture number 3 and this is the beginning of module number 2. Before I get too far into the material today, I want to go over just a couple of logistical things from the class and hopefully make sure that everybody is keeping up with where they're supposed to be. So the first thing is that all of the lectures before now, which were lecture 0, lecture 1, 1.5, and 2, those comprise the material for module number 1. Which was the material for week 1 of the class. So that's what you should have watched before you got to this video. When you're done watching that, you should be able to take quiz number 1. So if you haven't already attempted quiz number 1, please note that you have until August 30th to complete that, which is about a week from today as I'm sitting here recording this, but of course you may be watching this on a different day, so make sure you're checking your calendar. It is due by August 30th. When we say something is due on a day, it's usually due at midnight of that day, meaning 11:59 p.m. of the day. What is much more urgent is that the syllabus and policy quizzes are due on August 23rd, which, as I'm recording this on a Friday, that means they are due this coming Sunday. I'm going to send out an email today just to remind everybody to get that done, so that needs to be done very soon. So Module 1 was a review, and hopefully that was helpful. As another logistical point, I do have office hours. They are twice a week. They're on Tuesdays and Thursdays. The Tuesday one is earlier in the day and the Thursday one is later in the day, and I did that just so that some people may work or have classes or something else that makes it hard. You're never required to come to office hours, but if something didn't make sense in the slides or you're having questions about something that's going on, I'm always happy to talk with you. I will be there in the Collaborate Ultra session during the times of my office hours, so you can just pop in, ask a question, and pop back out again if you need to. You can also obviously send me an email at any time, and I'll be happy to answer it that way as well. I have had a couple of people ask questions about quiz 1, and I'm happy to answer them at a high level, but the problem is because some people haven't taken the quiz yet, I can't give you the answers or show you the questions and what you did until the quiz is over. So I will address quiz 1 at the beginning of module 3. By that point, quiz 1 will have been completed and everybody will have submitted it. So that'll become part of these lectures that you're getting in the video recordings. You'll get a little overview of the quiz as well. All right, so that is the logistical updates on where we are. Hope you guys are all doing well and staying healthy. I'm going to talk today about reference parameters in this video. In the next video, I'm going to talk about the static modifier, and that'll be a shorter video. And then in the third video, we're going to cover array lists and iterators. And that will comprise all the material for module number 2, which is what we're hopefully working on this week. Hopefully you guys are doing well in your labs and you're working your way through them as well. And yeah, without further ado, I'll go ahead and get started. So as I said, today we're going to talk about parameters, overloading methods, and random garbage, because you need to talk more about garbage. So the first thing is that there's a couple of different ways that you can pass information into a module, into a method, and those are you can pass it by reference or you can pass it by value. In C#, there's also the concept of passing out variables. We'll talk about that in just a minute. We're also going to talk a little bit about garbage, which is how memory is cleaned up. And I'm going to do a little bit of a deep dive into how memory works with Java in general. It's not just Java, it's also C# and pretty much all languages, to be honest. And then we're going to talk about the ref keyword in C#. All right, so to start off with, let's talk about what a method is. And we've mentioned this before. This is not new information. A method is an encapsulation of a bunch of different syntax that you wanted to execute together. Typically, a method does one task. So usually you would have a method that, multiplies numbers by some constant or does whatever it is that it's supposed to do. Ask a user for some input, record the input, validate that they gave a good input, and then return it or something along those lines. Whatever the method is doing, all methods pretty much work the same way. You have a header for the method, which specifies what's coming in, what's going out of the method, and what type of method it is. And then you have a body where you actually write all of the code that's going to do whatever it is that you want that method to do. It's useful to think of a method as a black box. It's just something that has stuff that goes in, stuff that comes back out again, and it gives you the result that you want. All right, so as I mentioned, there's a header and there's also the body. So let's take a look at the header. The header of a method, which you've seen before many times, is going to have many of these items, some of them are optional and most of them are not. So the first thing is you're going to specify some modifiers. In this case, this method is being listed as public, which means that when you instantiate this class into an object, this method is available to the calling program. It is static, which I'm going to have a whole video talking about that one later, so we're going to skip over that word. And the return type of this method is an integer. So this method is going to return one integer back after it completes executing. The method name is add2numbers, and again, that's just an arbitrary string that somebody picked to name this method. Hopefully it's somewhat descriptive about what the method is doing. And then we have the formal parameters, which are the list of things that are coming into the method for us to manipulate inside the method in one way or another. In this case, we have two integers that are coming in. We're calling them x and y, which are maybe not the most descriptive things. And then we have the body of the method, which in this case simply returns x plus y. So none of this is particularly new. I just wanted to have a base so that when we talk about the next thing coming up here, we can have something specific to look at. So if I were to go ahead and call this in some other method further down, I would say int, because I'm getting back an integer. That has to match this, or it should match this. And I'm calling my result, because, well, that's what it does. I'm going to add two numbers, and I'm passing in 5 and 2. Okay, these two are called the arguments. These are the arguments that are going into the method. Up here, they're called parameters. Down here, they're called arguments. The wording isn't that important. The key point is I'm taking a literal number, in this case, the number 5, and I'm passing it in as a parameter to add two numbers. When it gets up here, it will be assigned the local variable x inside of this method. And that's the important part here. So this x, as you probably are aware, is local. Oh, I changed slide. Going back. All right, this x up here is local to this method. And what I mean by that is, as soon as you get to this curly brace that ends that method, or more specifically, when you hit the return that exits out of that method, this local x that was created at the time this method was invoked goes away. It's no longer available. And likewise, the same for this y. The return that's coming back from it, you may or may not capture it. And in this case, we are capturing it. We're putting it into a variable called result. But that's the only actual information that survives the ending of this module executing, this method executing. I keep saying module, sorry. So in this case, we passed in two literal numbers, the number 5 and the number 2. But the arguments could also be variables. Down here, I could have another variable called x and another variable called y. Or I could have a variable down here called Bob and a variable called Sue. They don't have to match the parameters that are actually coming into the method. So when there are two different sets of variables, the arguments being one set of variables and the parameters being another set of variables, what actually is going on there? What's happening? And the answer is that by default, in both C# and in Java, what's happening is a copy of the value that's here is getting passed in and assigned to the variable up here. So this 5 is being assigned to the x. Even if this had been a variable called Bob, the value of Bob is being assigned to the x. And likewise, the value of Sue is being assigned to the y, or in this case, the literal number 2 is being assigned to the y. So these variables that may be down here in this other module method are not the same as these variables up here. They may have the same name, but they are not the same variables. And so that's an important distinction that I wanted to go over. All right, so the default behavior is that anytime that you call a method and you pass something to it, a copy of the value of the variable that you pass is what's actually going to be passed. That is the default. Java does that, C# does that, Java and C# do that. You can, in C#, ask it to pass a reference to the variable that's down in the other method. And I will explain that in a moment. The use of that is done through a keyword called ref, which you would put on both sides on the argument list and also on the parameter list. You do that when the variable needs to change inside the method that you are calling. So I'm going to give an example here in just a moment, and I'm going to show you what I mean by this. But if you have a variable, if I go back a slide here, and I have a variable down here which I called Bob, And up here inside of this method, I change x. That doesn't change Bob because Bob was a separate variable. If I wanted to be able to change Bob, which there are some circumstances that you might want to do that, then you'll need to pass it by reference, which is only available in C#. There's a different way to do it in Java, and we'll talk about that as well. All right. C# also has another keyword called out, which can be used if you just have a variable that you want the method to create and return. It's kind of like a return from the method, but it's a way to be able to return more than one thing. It is honestly not very commonly used, so I'm not going to spend a lot of time on it, but just be aware that the keyword out does something similar to reference, except it doesn't expect a value to go into the method. It only expects a value to come out of the method. All right, so Java passes everything by value. C# uses both call by reference and call by value, or pass by reference and pass by value is another way you'll see that written. All right, so let's go through an example of what I mean by all of this. So we're going to have a method here called main, and we're going to have another method up here called b. Down in our main method, and I'm sorry, the syntax of this is just so that you realize that you could capitalize, depending on the language, uppercase or lowercase string, depending on whether you're in C# or in Java, that's necessary, and you can capitalize the main or not. All right, so we have a main function, main method, and we are creating an integer called a, which we're setting to the value of 42, and then we're printing out a. And again, the print statement will be a system line print line or system out print line or a console.write, depending on which language you're in. But again, we're always just going to say print for example's sake. So if I print a right now, I'm going to get a 42. And that seems pretty obvious because I just set it to 42. Why wouldn't it be 42? Now I'm going to call b, which is a different method, and I'm going to pass it a. And when I do that, I'm going to come up here, and it is a pass by value because that is the default regardless of which of the two languages we're doing. So since I didn't specify, it is assumed that this is going to be a pass by value. So this a is 42 down here in main. Up in b, we're going to have a variable called x, because that's what's listed up here in the parameter list. And our argument a is going to get copied into x. So at the beginning of b, x is going to be given the value 42. The very first thing that happens in here is that x plus equals 9. All right, so as you remember, plus equals is a method for adding a number to the existing number. It's an equivalent to writing x equals x plus 9. So x plus equals 9 means that our original 42 will have 9 added to it, which will bring it to 51. So by the time I do this print x up here inside of b, the value of x is now 51. When this method exits, which happens now because there's no more statements, and I come back down here, the question is, what is the value of a at this point? And the answer is the value of a is still 42. A did not change. Up here, x changed, but that x is local to b. It is not the same as a. It is simply a copy of the value from a, and then it was manipulated, and then it died and went away. Terrible accident. So when we print a down here at the bottom, we're going to get 42 again, even though at one point up here we did change what the variable x, which originally had the same number as a. All right, I hope that makes sense. So it is a copy by default. All right, so we're going to do another example here, and this time we're going to use the ref keyword. So this example is a C# example very specifically. So most of this code is exactly the same, except that we have added in the word ref in two places. Down here in the argument list, and up here in the parameter list. Other than that, this code is the same. I mean, they did write out console.writeLine just because it's C#, right? All right, so we're going to go through this again and do the exact same thing. So we create a variable called a, which is local in main. We set it equal to 42, and we print it out, and indeed we're going to get 42. But this time, when we pass a over to b, we are not passing the value, we are passing a reference to a. So in actuality, what happens up here is that x, which is a new local variable name up here inside of b, x is effectively a reference to the same block of memory where a is. And I'm going to draw this out in just a second to show you what I mean by that, but what you need to understand is that because you use this reference word, A and X are both pointed to the exact same place in memory. And so anything that happens to A down here also happens to X up here. And most importantly, anything that happens to X up here also happens to A down here, because it is the same variable, simply because you put in the word ref. You're passing a reference to the variable instead of passing the value of the variable. All right, so if we continue on with this code, when we printed this out, we got a 42 down here. I then called B and I passed it a reference to A. So X points to the same place that A did. So when I say X plus equals 9, I'm taking the value of A, which is 42, and I'm adding 9 to it, which is now going to be 51. And when I print it out up here, I will get 51, but most importantly, when I print it out down here, I will also get 51 after I return from the method, because that A and that X are actually the same variable once I put in the keyword ref. And again, this is only valid in C#. In Java, you would do this slightly differently. Okay, so let's talk a little bit about how that actually looks inside of memory. And I'm going to use this little tool over here, and hopefully, can I move this window? I can stick it up here. Great. Okay, so hopefully this will allow you to see how this is all working. So there are two areas of memory that you need to be aware of in pretty much every language. There is an area called the heap, which, as its name suggests, is just a blob of memory. And when I'm talking about memory, we're talking about literally the physical memory in your machine. It has a big area, so think of it like a sheet of paper. It's blank pretty much when you start off. I mean, there may be junk in there because, well, who knows? But effectively, it's blank, and you can write different things on that sheet of paper as time goes on. Each one of those things that you write are going to be variables. So when you say int x equals 7, what's really happening is you're creating a little blob of memory over here inside of the heap, and you're calling it x. And now you can put numbers into x. And when you do that, because in this case it's an integer, I think I said x equals 7, then that's effectively what it looks like. You may have hundreds of these variables sitting out in the heap, and as the program runs, all these variables that you've been creating willy-nilly end up being out here. This is a primitive type because it's an integer, but you could also have an object out here. So we've talked about you might have something like a car as an object, or you might have a dog as an object, or whatever else. So we'll make an instance of a dog at the time that you say Fido, dog Fido equals new dog. At the moment you do the new dog, a piece of memory is allocated, and it is given a name, Fido in this terrible example, and that blob of memory may have attributes in it that were in the object definition when you originally wrote it as a class. And Fido will live out here in the heap. This is all going to get very sad in a moment, but anyway, Fido is going to live here in the heap as long as Fido exists as an object in your code. At the end of your code, when your program exits, everything that you created in the heap will be cleaned away. And that includes poor Fido. He will no longer cease to exist, or he will cease to exist. So effectively, the end of the program, you can think it as the eraser comes along, and the eraser totally doesn't work because reasons. See, now this is what happens when you pick a new piece of software and you try to use it. Yeah. Okay, well, that's super annoying. Right. I guess the only way to get rid of it is to select the things because I put them in there as that. Boy, that's annoying. Can I backspace? I can. All right. Okay. Now that I know how to use my little program, sorry, I'm used to having a whiteboard, and when you pick up the eraser, the whiteboard erases. It's crazy. But here we are. All right. So that's the heap. It's a place where pretty much all of your variables get created. So if that's true, then what the heck is this stack over here on the other side of the screen? Well, the stack is an area where each of your methods get a blob of memory. So think of the stack this way. When I invoke a program, the main method is run. And that's going to immediately create another little blob of memory that's in the stack. But it is specific to the main method. If the main method then calls another method called do something, then that will create another blob on top of the stack, which will be called do something. Now, you might say, okay, cool, why? And the answer is because you know that when you create variables inside of a method, they're local to that method. We've said that many, many times, but what does that actually mean? Well, it means that the variables are stored actually in the stack when they are local to the method. When they are not local to the method, they're actually stored in the heap. So let's take a look at that example that we were looking at just a moment ago. I'm just going to go back to the code. So it had two methods. It had a method called main, and it had a method called b. So let's walk through what this would all look like at the time that it's running. So before that, I'm going to get rid of this do something because that's not what it's called. All right, so when the program starts up, the current state of everything is going to theoretically be like this. There is nothing on the heap, and we are going to have an evocation of main, and main is going to get allocated a block of memory on the stack. The very first thing that happens in main is that we create a variable called a, and it has a value of 42. So what's going to happen there is, think of it this way, you're going to have an int a, and its value is going to be stored in the heap. But the a itself is stored in the stack. The name of the variable is in the stack. The actual data is stored over in the heap. So I'm going to draw a little box over here, and the number that got put into it is, of course, 42, the answer to the universe and all things. So 42 goes in here. And then what you need to think of it as is that effectively this int a that we have over in the stack ends up being a pointer to this block of memory in the heap. Now, I use the word pointer, and that probably makes you shudder because you've probably been through 1321 and at some point they mentioned pointers and your brain went, poof. But don't panic, it's nothing scary, it's just a memory address is really all that's going on. If you think of it this way, if you had a page of college-ruled paper, you could put line numbers on each one of those lines in the paper, right? So, like, here I am with a piece of paper over here. Ta-da! All right, so over in the margin, I could number all of these lines. So I'm going to say this is line number 1, that's line number 2, that's 3, that's 4, and so on and so forth. This is kind of like how memory works. Right now they're all empty, there's nothing in there. The 1, the 2, the 3, and the 4, those are addresses of memory. And so I might be able to then say, into address number 1, put in 42. And then, bada bing, it's now in there. I may have a variable name that I'm keeping track of called x that effectively says the value is stored in address number 1. Now the good news is you don't have to keep track of all these addresses. That's why we have programming languages. And the truth of the matter is you couldn't, because there are millions of them or billions of them depending on how much RAM your computer actually has. The size of this block is determined based on the type of variable that you created. So you'll remember that when we talked about the primitive types, they have a specific size, and that translates into a number of bits. And you have a certain amount of RAM in your computer, so at the time that you allocated that integer, it is going to take up some of those bits of the memory. And when I say they're allocated, the moment you create int a, so if you had not initialized it to the value 42, if you just said int a semicolon, at that moment in time, that block of RAM, of memory, is created and it is now allocated to that variable, and no one else can have it. And who keeps track of that? Well, that's your Java virtual machine or your runtime environment or your compiler, depending on the language. It just makes sure that whenever that memory location is allocated to you, it is yours and no one else can mess with it. Only you can decide what's going in and out of that particular block of memory. So this is important because that block of memory is going to be there until you tell it otherwise. It is theoretically possible, by the way, to completely fill up the heap. There is a physical size to this, and it's determined by a variable that's actually set at runtime when your machine runs. it's obviously dependent on how much RAM you have. Part of this is what explains why sometimes you try to run something and your program crashes and it says out of memory. It probably means you ran out of heap space or you ran out of stack space. Either one is possible. And you'll see as we get into recursion that stack space is a lot more common when you're in recursion, because you could create many calls to a function, and that could quickly eat through the stack space. If you start copying huge data structures in, you might exceed your heap space, because again, the size is allocated based on the size of the variable, not based on what you put into it. The moment that you create the variable, the space is allocated whether you like it or not. So theoretically, you could write a program which just says int A, int B, int C, int D, int E, and so on and so forth, and eventually you would run the machine out of memory. You'd have to go for a long time on most modern machines, but it is plausible. Okay, so that's a very long answer to what happened when this line of code executed. Int A equals 42, put a new variable, which it called A, in the stack, and pointed to a little blob of memory in the heap, into which it stored the value 42. Cool. So what happens next? Well, we print that out. Okay, well, that's pretty easy. That doesn't change the situation in memory. So the next thing that happens is that we're making a call to a new method, which is called B. So what needs to happen here in my stack is I'm going to get another instance of a method, and this guy is called B. So that happens the moment that I call the method. B says that it has a variable called x, which is an integer. So up here, we know that we're going to get int x. I think it's automatically capitalizing my I, and I apologize for that. And also this A down here should have been lowercase. I'm just going to correct those in case that gets confusing to anyone. All right, there we go. All right, so as I said, int x is created at the moment that B is invoked. We know this because we specified in the argument list that x is a variable inside of this method. Now, I'm going to back up to the other slide, the one before we put in this reference word, and I'm going to show you what happens in this one, and then I'm going to show you what happens in the one with the reference. So to be clear, we are back looking at the one that does not have the word reference. So we are passing by value. So what happens in this circumstance is at the time that B is created, x is given a new blob of memory, and the value that was in A is copied into it because we passed by value. X is a happy little pointer over to this blob. So this probably explains what's about to happen, because inside of my method B, I'm now going to add 9 to the number x, or to the variable called x. And as you can see, when I do that in B, I'm going to be modifying this guy, and this other guy down at the bottom, he doesn't care. It's a completely different blob of memory. So I'm going to do that. I'm going to add 9 to this value. And of course, what that means is that 42 is going to become 51. So now up here, when I print x, it's printing this value, which is 51. So out onto the screen pops my 51. When this method ends, something is going to come through, and it's going to remove this off the stack because its execution has ended. And at the time that it removes it, I mean, it's effectively going to do this, right? That's going to get removed, that's going to get removed, and as soon as that goes away, this has to go away. Which also means, by the way, that that little pointer that's sitting there is no longer valid. Now I think the eraser thingy will work. Hey, look at that. So you might say to yourself, okay, cool, what's happening to that block of 51 over there? We'll talk about that in just a second. But the method B has exited. So it has come off the stack and all of its variables have been erased from memory. Down here, we go on and we print A, and as you can see, A has not been changed by any of that, so A is still equal to the number 42. So it prints out 42, and that answers what's going on there. Let's go through the other example, and then I'll come back to what happened to our poor little 51 up there. All right, so in the other example, the thing that was different was the keyword ref, which means we are passing by a reference into that method. So the thing that's different here is we're still going to get a new item on the stack because B indeed is a new method call, and that's going to create a new stack, and it is still called B, so none of that has changed. What has changed is that my little guy called X, which is still an int, in this case, he was passed a reference to A. So what he actually ends up looking like is he becomes this. He is a reference to the same blob of memory that we had when we were in the main method. So now, when I do my code of x plus equals 9, you can see exactly what's going to happen. That 42 is going to get updated to 51. Easy for you to say. Typing on a whiteboard, not easy. Okay, well, you get the idea. 51. Ugh. So much easier with markers. All right, 51. There we go. And so now you can see that when I print out x, it's going to print out 51. And when this method ends, all of this stuff is going to go away just like it did before. We're going to go back to our main method. This weird little line is going to go away. And we are left with A pointing to that same block, but that block has been updated. And that's why in the reference case, we got 51. So I hope that makes sense. So it's really, really important whether you're passing by value or passing by reference. And you might wonder, why would you ever want to do this? Like, this seems crazy. Obviously, this example is a bucket of crazy, but there are many times when you're coding something that you may need to update a variable that you have in your main method. And if that's true, in C#, you're going to pass it by reference into the method. What about in Java? Well, we're going to talk about that in just a second as well. All right. So the out variable, or the out keyword, as I mentioned, is not really something that I'm going to spend a huge amount of time on because it's not really that relevant. You're probably never going to use it, but if you say out, it does point to it works pretty much exactly the same as ref, except it doesn't care about the value going in. It only cares about the value coming out of the method. All right, so we're just going to move on. All right, so this is the example without. In this case, you're passing out integer a, you're passing out a up to this variable. This again is going to look the same as the reference example that I did. When x is set to 9, it is also changing a. And when you print x up here, you're going to get 9. When you print a down here, you're going to get 9 because it got set by the variable. So that's the out parameter. So we just talked about what's going on with primitive data types when you're passing primitive data types from one method into another. But let's now talk about more complex data types. And to be clear, when I say primitive data types, I mean ints, longs, floats, booleans, those types of things. More complex data types might include an object that you've created. So with classes and objects, you're still passing by value, but the effect is slightly different because what you're passing is a reference to the object. You're passing the value of the reference, but you are passing a reference. So I'm going to explain that because that's a little bit confusing. The behavior is also going to be slightly different than what you were seeing when we were doing the primitive data types. So let's take some code here. We're going to deal with our dog again, poor little Fido. So we're going to have a class called dog, and it's going to have a variable in it called weight, which is a public integer. And that's the only thing that the dog has, just a weight, apparently. All right, so we're going to start off in our main method, and we are going to instantiate a new dog. So over here on the right, we can see what's happening. A new blob of memory is allocated in the heap, and my dog, which is going to be in the stack of main's method, is going to effectively point to that space in memory. And then inside of that space in memory, we have a variable called weight, which is 0. Because it's initialized to 0 by default because constructors. All right, so that instantiates a new dog. So that was the first line. So let's move on to the next line. What happens next? So my dog's weight equals 10. So my dog dot weight, my dog is the variable that I just created, and its weight, which is the variable inside of it, inside of that object, is set to 10. So we update that. So far, nothing surprising or weird. If we print out the dog's weight, of course, that's going to print 10 to the screen. So now we're going to make a call to B. And B is another method that's defined up here, just like we were doing in the previous examples. The things that are different here are dog is not taking in an integer like it was before, or sorry, B is not taking in an integer like it was before. It's now taking in a dog. It's still calling it X, and it's changing the weight of the dog. So let's talk about what happens at this step. So at this step, a new chunk is added onto the stack, just like it was before, and a new reference is created here called X, because X is a parameter to B. And if we look over in memory, then this is effectively what happened. This X is associated with this stack entity, the call for B, but it is pointed to the exact same object or the exact same blob of memory in the heap. So when we are inside of B, if I update the weight, if I say x.weight plus equals 9, I think you can see what's going to happen. When I follow x to the object in the heap, and I access the variable weight inside of that, and I update it, this 10 is going to update to 19. So what does that mean to the other original my dog down here in main? Well, since they're both references to the same object, they both see the weight has changed. Now this is again different than what was happening with the primitive types. In the primitive type, I got a whole new blob of memory that I was able to mess with when I called method B. But here, I get a blob of memory, but it is just a reference to the original object. And therefore, when you pass an object into a method, you are still passing it by value technically, but what you're passing is the value of the reference. And therefore, when you make changes to the variables inside of that method, inside of that object, you are updating it for everybody. It is inherently a reference that you got, therefore you are updating the original variable for both. I hope that makes sense. So our weight is now 19, and when we print out the weight inside of the method up here, we're going to get 19. And when we print out the weight down here inside of main, even after this has popped off the stack and this variable x has gone away, you can see that my dog still has a weight of 19 inside of there. So the dog's weight changed when we made a pass, when we passed a reference to the object. So what happens if I put in the keyword ref on front of this? How does that change anything? So we're going to do the exact same code again, and we're going to do one additional line this time, just to prove a point. So we start off and we make my dog, and it has a weight of 0 because of the constructor, and then we're going to set the weight to 10, and all that's the same. We're going to print out the weight. We know that's going to print out 10, and then we're going to call B. But this time when we call B, we're calling B with the reference my dog, and we're receiving in as a parameter the reference of type dog, and we're calling it X. So what does that actually look like? Well, over here, what actually happens is X is literally the same reference to the object. It's not a whole new reference to the object, which is what happened in the other one, because in the other one, we were making a new value, which was a copy of the reference. But here we're not making a copy of the reference, we're actually passing the reference. And you might say, okay, cool, why are we doing this? Well, we're just going to prove something here real quick. The very first thing that happens in B is I'm going to say X, which is my reference in my local variable in here, gets new dog. And boom, what's going to happen is X and my dog, because they are the same exact reference, now point to a whole new dog who has weight of 0. I'm then going to set weight equals 9, and I'm going to print it out, and as you would expect, what's going to happen here? An important detail is that I have created my first instance of garbage, which is a very specific word. It's literally called garbage. The moment that I moved the reference for my dog in the main method, and the reference for X in my B method, the moment that I moved that to a new dog, the old dog is no longer accessible by anything. There is nothing referencing this blob of memory. It's still technically there in the heap for right now, but there's nothing accessing, there's no way to access it. I have no variable that will get me to this blob of memory. The only variable I have left here is this new X. So what's going to happen to this old dog that was down here? Well, the answer is there's a magical process called the garbage collector who is going to realize that there is no reference left to this memory in the heap, and it's going to reap it, which basically means it's going to go in and remove this blob of memory and make it available again. It's going to make it free for anybody else to use that chunk of memory. Our dog is gone. To be clear, the moment that you changed away the reference, there was no way to ever get back to this dog. And even if this hadn't happened during passing parameters, it would be true. Like if I had said in my main code, and I'm just going to go back to the code on the previous slide. So even before I went off and called this method B, if I had said dog my dog equals new dog, and then immediately after that said my dog equals new dog again, the first dog is gone because I've updated what my dog is pointing to. I now have a whole new dog. So just to be clear. All right. So in this case with the reference, because they are actually the same reference or the same pointer, we're not going to use the word pointer because it's scary, but they are effectively arrows or pointers to a blob of memory. Because I updated it, I am going to break the connection to the original one. That's what happened when I did new dog. At this point, I set x.weight equals 9, and that indeed sets the weight up here, because that's where the reference points to. I print out the size, and of course, the weight, and of course I'm going to get a 9 on the screen because that's what's there. And then when I come down to the bottom, the x is gone now, but my dog is still pointed to the same place. And so when I print this out, I'm going to get a weight of 9. The dog that has a weight of 10 is forever gone. There should have been a warning at the beginning of this video, bad things are going to happen in case you did not know. All right, so the question is, am I really talking about pointers when I keep saying pointers? Because I do keep saying pointers, and I'm really trying not to say pointers, but, well, yeah, I am kind of saying pointers. The answer is yes. Effectively, a reference is a memory address, and there's no way for you to directly manipulate it. So that's why it's slightly different, but it is a reference to a chunk of memory. Over in our stack, it is a reference. All right. So we keep talking about this ref keyword, and I've said many times that it only applies in C#. It doesn't exist in Java. So how would you update something in a method or in a class or an object in Java if you'd have no way to pass in a reference to the original one? And the answer is, well, you would just have a method that updates it. So in this example here, we have a method called changeX, and it takes in X and it returns X. So you can see that what's coming in and what's going out of this method are the same variable. As a result, this method is doing the same thing as passing a ref in C#. It is allowing you to send information in and get information back out of the code. To be clear, this is still passing by value. It's just that you're getting back the value and you're updating your method that you were making the original call from. All right, so we're going to try and clarify these words. Pass by value means that whatever the variable is that you are passing, a value is going to be copied from the calling method to the called method. Passing by reference, we are sending over the actual blob of memory for us both to be able to manipulate, both the calling function and the caller. And then pass by reference type is what we're describing here when we were dealing with an object, where you are passing a reference and it is a copy of the reference that you're originally passing, but they happen to be pointed at the same blob of memory. All right, so that completes the discussion on pass by reference. I hope that starts to make sense, and I hope memory allocation makes a little bit more sense. I'm going to jump back over to this picture that we had, and I'm going to go back to something that I mentioned much earlier in the video. When we had created a new entry on the stack for B, and we had another variable in there called x that was originally pointed out to this chunk of memory in the heap, I mentioned that when that goes away, when that method ends, the reference to this blob of memory also went away. And so much like what we just described with the more complex types, this will get cleaned up by the garbage collector. The details of the garbage collector are not particularly important, but it is important for you to be aware that it exists. It is this process that is running simultaneous to your program that is looking at the heap and deciding if there are things that need to be cleaned up. If the garbage collector is not efficient enough, you could run out of heap space, because even though you created a variable and then exited that method and you expect the variable to be gone, it is actually still taking up space in the heap until the garbage collector gets around to cleaning it up. For every program that you're going to write in college, this is never going to matter because you're not going to come anywhere close to saturating the heap. But as you get into bigger and more complex things, the efficiency of the garbage collector actually becomes an important thing. And very strangely, there's no simple answer to how aggressive the garbage collector should be, because sometimes you want the garbage collector to be very aggressive, meaning cleaning up everything as soon as it's no longer referenced, so that you can have the heap space back. But there's a cost to doing that, because obviously the garbage collector is using up resources on the computer. It's taking up CPU time, and that is competing against your actual execution. So it's a question of what's more important, the speed of your execution or the cleanliness of your heap. And so what Java tries to do is understand approximately what's going on. This is true for C# as well, and how often that garbage collector should be running to clean up your data. So the details of all that, thankfully, are taken care of in the language. You just need to be aware that it's going on in the background, because you may eventually run into a circumstance in later life where the heap gets completely filled up and you need the garbage collector to be more aggressive, at which point you can go and research how to change the aggressiveness of the garbage collector. All right, so we're going to switch gears here and we're going to talk about something different. And the thing that we're going to talk about next is overloading methods. This is having more than one definition of a method that has the same name. The signature of the overloaded method has to be unique, and what I mean by that is if you're going to have two different methods, they must have something that is unique about them, otherwise the compiler is going to complain. So you might have a number of parameters, or the order of the parameters that are being passed in, that would differentiate it. I will warn you that the return type of a method is not part of the signature. So what I mean by that is, if I have two methods that take in one integer each, and one of them returns a double and one of them returns an int, they cannot have the same name. They actually have to be different names, because they would have the same exact signature as far as the signature is concerned, which is the name of the method and the two or however many parameters are going in. So if I have a method and it takes in one int and another method with the same name that takes in one int, that's a problem. If I have a method that takes in one int and another method that takes in one float, and they have the same name, we're cool, no problem whatsoever. But if they're the same exact parameters, then you have a problem. All right, so overloading a method is having the ability to have more than one way to call the same method and pass it different parameters or different arguments. So if we take a look at this example here, we have the try me method, which we have two different definitions for. One of them takes in a single integer, which we're calling x, while the other one takes in an integer and a float. And you can see that the body of the methods do whatever the bodies of the methods do. That's not really relevant to this particular conversation. The point is that I can call these methods separately. And you might say, Well, how does it know which one is being called? So, like, I'm here down in a main method, and I'm saying try me 25 4.32f, which is a float. How does it know, do I mean this one or do I mean that one? Well, the answer is it looks to see what are the types of the two parameters that I'm passing in, and it decides which method matches the best. So in this case, I'm passing in what looks to be an integer and what looks to be a float, so it's going to match this. If there is no matching method, then it's going to complain and you're going to get a compile time error because it's going to say there is no matching method. All right, so this is the idea of overloading a method. Both C# and Java support overriding methods, and it is a useful way if you have two different calls that you might want to make with slightly different types, but that do the same thing. So, in this case, try me is kind of a vague term, but perhaps you want something that adds numbers. Well, the way that you add numbers may be different if they are two floats versus if they are two integers. Maybe you want the floats to be rounded in some way, or you only want a certain amount of precision to come back. So in that case, you would define the same method as you have for the integers, but this time with floats as the input, and then they will behave slightly differently depending on what you pass them. So that's the idea of overloading methods. You can also overload operators as long as you're in C#. Java does not support overloading operators, so if your language of choice is Java, then this is really not going to matter to you. In Java, what you would do is you would just create a new method and you would call it something similar to what the original operator used to do. So, for example, here we have the plus operator, which is a plus sign, and in C# you can redefine what plus does given certain circumstances. In Java, you can't do that, so you would probably just have a method which you would literally call plus, and it would take in two parameters, and then it would return back whatever it's supposed to. But in C# and also in C++ for that matter, it is possible to override operators. You might say, well, why would you ever want to do this? So let's take the example of you're dealing with a mathematical matrix, and you want to be able to add a matrix to a matrix. Well, it would be nice in your code if you are able to define a class of type matrix, and then it has the parameters and it has whatever methods it may have, and then you might want to override what it means to add a matrix to another matrix. And in that circumstance, there's if you remember this part of Algebra 2, I think, was this Algebra 2? I think this was Algebra 2, where you would add two matrices together, then there's a particular method for doing that. So once you have written the override code, then at that point in your main method, you can simply say matrix, assuming that's the name of your class, P equals new matrix, matrix Q equals new matrix, and then you can say P plus Q using the plus operator, and your code will know what to do with that. It is pouring rain outside the window at this moment. All right. So that is operator overloading. C# allows you to override most operators to make them sensitive to the context of what you're trying to do. Use operator overloadings when it makes an application clearer to accomplish the same operations with explicit method calls. So what they're saying here is, if what you're doing is adding, then just add, right? Make an override for the plus sign, and then that allows everybody to just add one of your objects to another one of your objects without having to have any understanding of other methods that you have defined. Again, in Java, you're just going to have to call a new method. So that completes the lecture today on, oh no, there is one more slide. I just didn't get to it. So here's an example in C# of overriding the plus operator. We are adding dogs together, yes. Not really sure what that means, but we're going with it. All right, so up at the top we have class dog, and each dog has a name and a weight. And we have a constructor for dog, which sets the name to whatever name is passed in and the weight to whatever weight is passed in. Pretty simple stuff here. And then in the dog class, we are defining an override for the operator plus. So we're saying public static dog operator plus dog1 and dog2. This is a binary operator. It has two parameters. The plus sign always has two parameters. When you're dealing with two integers, obviously they would be two numbers. So when you're dealing with two dogs, you have to have two dogs. And so what we're doing is we're creating a new dog called combo dog. Not really sure what science is going on here, but anyway, the dog's name is going to be D1, which is our first dog that was passed in, appended with a colon, appended with the second dog's name, so it'll be Fido colon Spot. And then the weight is going to be the combined weight of the two dogs. So we're adding their weights together and we're returning a merged dog. So down in our main method down here, we can see we create a new dog, which we call CSE. Does that make sense? And it has a weight of 8. And then we have another dog, which is called 1322, and it has a weight of 9. And then we are literally able to say, my dog, which is this variable, plus your dog, which is that variable, becomes the uber dog, whatever that may look like. And now we're able to print out that answer. So hopefully that gives just a quick explanation of how you would override an operator. Again, only relevant in C# and C++, but not in Java. Okay, so that really does end today's lecture for parameters, references, and overrides. In the next lecture that I'm going to record here in just a second, we're going to talk about the static keyword, and then there will be a third lecture this week, which is discussing iterations and array lists. So I'll see you in those videos. Hope you guys are doing well. And now I'm going to awkwardly stop the video.